viewers, welcome to Learn Computer KC channel. In this video, we are going to discuss about subgraph, path and representation of a graph. These topics are taken from the book Fundamentals of Computer Algorithm by Ellis Horowitz. First of all, we are going to see subgraph. If a graph is said to be a subgraph of a graph, when the vertices of a graph is subset of another graph and the edges of a graph is subset of another graph. In this example, we have two graphs G and G dash. In G we have three vertices 1, 2 and 3. In G dash we have 1 and 2. G dash is said to be subgraph of G when the vertices 1 and 2 is subset of the vertices of graph G. The vertices of graph G dash 1 and 2 is also present in graph G. The vertices are set of graph G. So G dash is subset of graph G. The next is path of a graph. Path of a graph for a set of vertices is the set of edges that passes through source vertex to destination vertex. The length of the path is said to be number of edges that passes through source vertex from source vertex to destination vertex. In this graph, we have 7 vertices. We are going to find the path from vertex 1 to vertex 5. From vertex 1 to 5, we have 2 edges 1, 2 and 2, 5. So path of 1, 5 is 1, 2, 2, 5. We also write it as 1, 2, 5. The length of the path is said to be number of edges that passes through source vertex to destination vertex. Here from 1 to 5 we have 2 edges 1, 2 and 2, 5. So 2 edges. So length of the path is said to be 2. Next is cycle. If you find the path for a graph, if the path contains the first vertex and the last vertex as same, then the path is said to be cycle. In this example, graph G, we have 1, 2, 3, 4 as vertices. Here the path 1, 2, 3, 1 forms the cycle because the first vertex and last vertex is 1. So this path is said to be cycle. The next is representation of a graph. A graph can be represented by using two data structure. One is adjacency matrix, another one is adjacency list. Adjacency matrix is square matrix and the adjacency list is linked list. First we will see adjacency matrix. As I said before, the adjacency matrix is a square matrix. The rows and columns will be the number of vertices. This matrix is filled by the entries 1 and 0. If the vertices of a graph has a connectivity, so then the corresponding entry will be 1. If doesn't have connectivity, the corresponding entry will be 0. We will see by the example. In this example G graph, we have 4 vertices 1, 2, 3 and 4. So we have 4 vertices. So 4 cross 4 matrix will be there. In row and column we will write 1, 2, 3 and 4 the vertices. 1, 2, 3 and 4 we will write in row also and column also. Now how we will fill the entry means, first we will see 1, 1, row column 1. Here we have vertex 1 and vertex 2 we have connectivity. First of all we will see row 1 column 1. We don't have connectivity from 1 to 1. So in row 1 column 1 we will put entry as 0 because there is no connectivity from 1 to 1. The next is 1, 2. From vertex 1 to vertex 2 we have a connectivity, we have edge. So row 1, column 2, we have entry 1. The next is row 1 and column 3, from 1 to 3. Source is 1, destination is 3. We have a connectivity from 1 to 3. So we will write 1, 3 as 1. From 1, 4, 1 to 4 we have connectivity. So we will write it as 1, 4 as 1. The next row is 2. From 2 we will examine all the vertices. From 2 to 1, that is row 2, column 1. 2 to 1 we have connectivity. So for row 1, 2 and column 1 we will write 1 as entry. The next is 2, 2. 2, 2 we don't have connectivity from 2 to 2. So for row 2 and column 2 we will put 0. The next is 2 to 3. 2 to 3 we have connectivity. So row 2, column 3 we will put 1. The next is 2 to 4. 2 to 4 we have connectivity. So 2, 4 is 1. The next vertex is 3. Row 3, column 1, 2, 3, 4. So from 3 we have connectivity to 1. So we will put 3, 1 as 1. For 3, 2, 3 to 2 we have connectivity. So we write it as 3, 2 as 1. From 3 to 3 we don't have connectivity. So we will write 3, 3 as 0. For 3, 4, 3 to 4 we have connectivity. So we will write 1 as 3, 4. The next vertex is 4. From 4 we have connectivity to 1. So we will write 4, 1 as 1. We have connectivity from 4 to 2. We will write 4, 2 as 1. From 4, 3 we have connectivity. So 4, 3 is 1. 4 to 4 we don't have connectivity. So 4, 4 is 0. Likewise, we should entry the values to the adjacency matrix. The next is adjacency list. The adjacency list is the linked list. It is a linked list which contains vertices and the list of vertices adjacent to the particular vertex. In this example, we have 4 vertices. We will find the adjacency vertices for each vertex. First, we will examine vertex 1. For vertex 1, we have 3 vertices adjacent to it, 2, 4 and 3. How we will write it as? We will write all the vertices as nodes. We have node, we have data and link. In data, we will write the vertex name 1. In the link part, we will write the link to node 2. Here, for vertex 1, we have 2, 3 and 4 as adjacency vertices. So we will write 1 and the link to 1 goes to vertex 2 and the link from vertex 2 goes to node 3, as well as from 3 we have link to node 4. The next is vertex 2. For vertex 2, we have 2 adjacent vertices 1 and 4. For vertex 2, the link from 2 goes to node 1. The link from node 1 goes to node 4. For vertex 3, we have 2 adjacent vertices 1 and 4. So the node 3 has the link to node 1. The node 1 has the link to node 4. For vertex 4, we have 3 adjacent vertices 2, 3 and 4. From 4, we have link to node 1. From 1, we have link to node 2. From 2, we have link to node 3. Likewise, we should write the linked list. Thanks for watching.